function, and I'm asked to find f prime of x. Can anyone refresh our memory on how to start? What is the definition of f prime of x?
It's the limit.
Thank you very much.
As x approaches 0.
Careful.
As h approaches 0.
Very good.
F of x plus h.
Very
good.
good.
The difference questions.
I'm just going to plug it in directly, divided by h. F of x plus h minus f of x for this function divided by h. We have seen this before, and we know a few things have to happen. What are those things? Anyone can refresh our memory on what has to happen?
Everything without a h has to cancel.
Very good. And eventually,
the denominator
has to go away. Awesome. Great job. Perfect. So can anyone expand this for us, please?
Is it x squared plus 2xh plus h squared?
Very proud. Thank you. Good. As expected, these two go away. And as expected, the next step would be
factor out an h from the terms in numerator.
Very good. And 2x plus h. What would be the next step?
Simplify.
They're very good. Now I apply the limit operator here, so it will disappear. What is the answer?
2x.
Excellent. So we keep in mind from now on to remember x squared prime differentiated equals 2x. This should be carved in stone now. Good.
Isn't that just called the power rule, and you could just move
Indeed,
the
the power
exponent
rule
to the front and subtracted 1, and that's
it is the power rule. I completely agree. We're going to talk about it very soon. Yes. Let's also look at the square root, and then we'll look at problems in the book, so we can continue. So can anyone give us limit sh approaches 0 for this time is the square root of x?
It would be the square root of x plus h minus the square root of x over h.
Thank you very much, Liam. Good. What do we do next? Anyone?
Rationalize the numerator.
Thank you very much. By what? How?
Multiply by x plus h plus, or excuse me, square root of x plus h plus the square root of x over the same thing.
Very good. Indeed, because this has to be 1. Very good. Can anyone else continue? Can we get the numerator? And I will write the denominator. Anyone else?
Would it be x plus h minus x?
Awesome. Thank you, Charlene. Very good. As expected, these two go away. I don't want to write this. I don't want to simplify now. I have to write it again. So please. Yes. Now we apply the limit operator. So the limit goes away. Now what do I write?
1 over square root of x plus square root of x.
Good, awesome. How much is an apple plus an apple?
2.
2 apples. So from now on, carved in stone, we don't want to talk about this again. This is it. When we differentiate the square root of x, we write 1 over 2 times the square root of x. Okay? Good. I'm going to share my screen. Any questions? Any questions? Okay, I'm going to share my screen. Where are you guys? I see. Okay. So, no, I don't want to search. I want this. I want page 136. Was I in 136? Where's my keyboard? Okay. Yeah, probably is 136. Good, good, good. Okay, so let's open 136 or even 135. Let's go back one more. And let's look at some problems. As you see, we already did this. We didn't graph the function. We can draw the tangent. We can graph a function. We can graph either one and just determine the slope at a particular point. We can. We can choose another function. What we looked at was x squared and the square root of x. If you want to choose anything else, we can. If not, I would like to work on problem 18, which we already did. Find an equation of the tangent line to the graph of f of x equals x squared, which just did, and choose any of these points. Either a, b, or c, they're all the same. So we know that the derivative, so that's my page 4. So this is problem 18. Please choose any point you want, and then I'll stop sharing.
3, 9.
Very good. So we want to look at 3, 9. Perfect. So here it is. Good. So I already know that this function is differentiable everywhere. I know its graph. This is not a corner. The function is differentiable everywhere, and it has this function as its derivative. If at this point, let's say 3, 9, let's say the point 3, 9 is here. If I want to determine the equation of this line, so this is the tangent at this point, 3, 9. If I want to determine the equation of this line, I have the point. Can anyone refresh our memory on the equation we are going to use when we have a point? The equation of a line given a point.
Its slope.
Y minus y1 equals the slope times x minus x1. We reviewed this in R. Please go back to your notes and our notes. So I have the point, which is 3, 9, and I don't have this. But the slope is given by this function. This function will give us the slope of this tangent at 3. So f prime of 3 is the slope of the tangent line at 3, 9. Can anyone give us the slope then?
Six.
That's it. Awesome. So it's 2 times 3, f prime of 3. So now I have everything I need. Y minus 9 equals 6 times x minus 3. Remember, we have to distribute. 6x minus 18. I have to move 9 to the other side. It becomes positive. And then I perform the operations. I get 6x minus 9. What does this represent? Is the equation of this line. So if this function were the, let's say, distance function, I can tell you that 3 miles or 3,000 miles later from the starting point, the rate of change will be, I don't know, 6 miles per hour, 6 miles per minute, 6 miles, whatever the measurement unit is. You don't have to call me and say, look at your odometer and tell me how much you're driving. What is your speed at this point? No. If I have the function, I just plug it in. I'll tell you at any point in time what was my speed. Any questions on this? Okay, back. Let's see other types of problems. So all equation of the tangent line. Let's look at one of these problems here. List the points in the graph at which each function is not differentiable. The function is not differentiable at x sub 0 or x 0 or x naught. Why?
It's not continuous.
Not continuous. Awesome. Differentiable everywhere. What about at this point, x sub 3 or x3? No, it's not differentiable because it is a corner. Awesome. The same thing here. It's a corner. Same thing here. It's a corner. This is okay. 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 No, this looks like a corner. This looks like a corner. This is okay. These are okay, but this... So again, here, it's a little bit iffy because if this is one slope and this is another, this may be also a corner. This is a corner. This is a vertical tangent. Vertical tangent. Okay, moving on. Let's see what else is here. Okay, this caught my eye, number 33. Let's take a look. Draw a graph. So 33 on 136. Okay, draw a graph that is differentiable. It should be a graph of a function that is differentiable and has horizontal tangents, horizontal tangent lines at x equals 0, x equals 2, x equals 4. This is a good exercise. Let's take a look. Okay. So first of all, when I try to graph something like this, first I have to establish those points. So at x equals 0, somewhere on this line, at x equals 2, 1, 2, 3, 4, it says it has horizontal tangents. So horizontal tangent. So here's a situation. This is very important for what we are going to cover in this class. See, there is a turn here. Or a turn, in this case, it's a max. That at that point, the function will have a horizontal tangent where it has a turn, either a max or a min. Right here, horizontal tangent. At any other point, the tangent will not be horizontal. At any other point, the tangent will not be horizontal. Only at a turn, which in this case happens to be a minimum. So the problem is telling us to draw horizontal tangents at these points. And otherwise, the function is differentiable everywhere. Fine, not a problem. I'll do a turn when x is 0. I'll do a turn when x is 2. I'll do a turn when x is 4. And it can go on anywhere. So right here, when x equals 0, horizontal tangent. Here, when x equals 2, horizontal tangent. Here, when x equals 4, horizontal tangent. There are no corner, no cusps, no vertical tangents. So the function is differentiable everywhere. In other words, I will be able to find the rate of change of this function anywhere. Here it will be 0. Here, this point will be 0 because that's the slope. The slope of the tangent is 0, then the rate of change at this point is 0. Any questions on this? Okay, going back, see other problems. Interesting. So let's look at something like this. The end of day values of the Dow Jones Industrial Average for the week of December such and such 2013 are graphed below. Okay, so on December the 9th, it was here. December the 10th was here. December the 11th was here. December the 12th was here. December the 13th was here. Okay, and we have all those points, including this one, the minimum, if you want. On what day did the Dow Jones Industrial Average show the greatest rate of increase? Can anyone say anything?
13th?
Do we agree with that? Of course, right? So it's the only one. It's first of all, it's not a tricky question because it's going down on every day except this day. Okay. On what day it showed the greatest rate of decrease, where the slope is the steepest. So
From
all
11 to 12.
From 11 to 12. I think this is smoother than this. We can determine the slope. We can determine the slope. y2 minus y1 over x2 minus x1. There is no need because we see that this is not that as steep. But if we want to compare these two, we should just determine the slope. y2 minus y1 over x2 minus x1 and y2 minus y1 over x2 minus x1. And it will tell us which one is the steepest. I believe, according to what I see on the graph, I think that this is steeper, but why not? Let's calculate. Let me copy the points.